So when we look at New Zealand as a whole, it does look as if we've had some trend towards an increase in the amount of rain on the western side of New Zealand over the long term. So basically things are changing in New Zealand and changing in Nelson and not just changing globally. And I guess the question then is, what is the cause of those changes? Well, there's been a huge amount of scientific work done looking into this. And again, you will have heard some people arguing that it's all to do with fluctuations in energy coming from the sun or volcanic eruptions or things like that. But it's very clear from the research that's been done that those things can't explain, particularly the warming in the last 50 years or so. And again, going back to the IPCC, what those scientists concluded was that most of the global temperature increase, particularly since the middle of the 20th century, is very likely due to the increase in greenhouse gas concentrations. And we know, for example, there's 35% more carbon dioxide in the atmosphere now than what there was before we started, before the Industrial Revolution and cars and all of those sorts of things. Another greenhouse gas, methane, there's 2.5 times as much methane in the atmosphere now as there was 200 or 300 years ago. So we have seen big increases in those greenhouse gases, and when you actually look at the physics of what goes on and try and simulate it with computers and so on, it's very clear that that's what's been the cause of this overall upward trend. So that's where we've got to so far, and apologies for this being a bit technical, but the real question is what's going to happen in the future. Well, the problem about predicting the future for the climate is that it depends on what happens with greenhouse gas emissions. And hopefully, if many communities around the world do things like Code Red, and governments really get serious about reducing emissions, then we won't go down the track that's shown by some of these, at least upper curves here. But again, this comes out of the IPCC work and from running lots of climate models, looking at the changes we'd expect for various amounts of further greenhouse gas emissions. And those various scenarios for the future, the ones that don't have major efforts to try to reduce greenhouse gas emissions, give us a warming of somewhere between about 2 and 4 degrees Celsius for the globe over the coming century, and substantially more warming than that in some places. Sea level rise from that warming, as the oceans warm up, they expand, and that it makes the sea level go up, but also glaciers are melting. The IPCC report suggested there could be somewhere of the order of 20 to 60 centimetres of sea level rise over the coming century. There's been a lot more research going on since then. People are getting very concerned about how rapidly Greenland is melting. The science is still not properly sorted out, but there are people seriously suggesting that we might see something like 80 centimetres of global sea level rise over the coming century, and even up to just over a metre. So that's enough to be quite concerning for coastal issues around the world, especially for people that live in those low-lying delta areas of Bangladesh, those sorts of areas. There are potentially millions of people at risk from those sorts of issues, and even in New Zealand, coastal erosion, storm surge, all those sorts of things are a concern. So that was what's likely to happen for the world as a whole. For New Zealand, this is from modelling work we've done at NIWA. We've looked at a whole lot of different climate models, and again we've looked at various scenarios, but if we look at sort of somewhere in the middle range there, we expect to get of the order of a couple of degrees or so of warming by the end of the century, fewer frosts, more westerly flows across the country, which mean we'll probably get more rain on the west coast, drier in the east, and some of the work we've done at NIWA suggests there's risk of substantially more drought as the century progresses, which is a problem for potentially for farmers who don't have, if they don't have irrigation water. And sea level rise around New Zealand, similar to the kind of global numbers that I've been talking about. And what's been talked about is enough to cause concerns, particularly in some parts of New Zealand. And in fact, I've got a little bit more about sea level rise. Too far there. There's just been, the Ministry for the Environment's just put out last week, in fact, a little summary document around coastal hazards and climate change, and making recommendations that councils and people can use. And those are suggesting that in terms of planning things for the future, we should allow for at least 0.5 metre of sea level rise. Look at how vulnerable something will be to 80 centimetres, and even consider the impact of a bit more sea level rise than that. So that's important, for example, if for coastal development, in terms of how far back from the sea you let people build houses and things. It's important for things like designing stormwater drainage for places near the sea, important for looking at developments near the coast. And that sort of sea level rise could put, I've seen some numbers for the Bay of Plenty, it could put many millions of dollars of investment in houses and so on at risk. So, even in New Zealand, which is much more resilient to climate than, say, some parts of Australia where they have a lot of drought problems already, we do expect to see some significant impacts from climate change. But the main reasons for concern about climate change are actually global and in some other areas of the globe. In particular, the IPCC looked at what the implications of various degrees of warming would be. And if we got 1.5 to 2.5 degrees of warming, the scientists that assessed this thought there were really significant risks to many ecosystems around the world, and particularly to low-lying islands, many of the Pacific islands, for example. Risk of extreme weather events such as droughts and heat waves and floods going up, and particularly the tropical cyclone issue I mentioned before. And the areas that seem to be most vulnerable actually are many of the low latitude and less developed countries. As time goes on, the economic impacts are likely to increase. For example, the Garneau report that was just done in Australia looked at what the economic costs of climate change, if there weren't major efforts to reduce emissions, could be for Australia. And they came out to be quite substantial over the coming 100 years. They essentially said that the costs of climate change, if there wasn't a major global effort to reduce emissions, would be substantially more than the costs to Australia of actually trying to reduce emissions as part of a global effort. And then there's one other concern, and I don't want to sound too sort of much about worrying about all sorts of things, but we know that 120,000 years ago, when the globe was just a few degrees warmer than what it is now, of the order of what we're talking about in terms of the warming we might see over the next 100 years or so, that sea level was 4 or 5 metres higher than what it is now, largely because of most of Greenland having melted. Now, it's going to take time for Greenland to melt, but the point is that if as countries we go ahead down the track we're on now, we are actually putting many future generations at risk of major changes. If we saw like 5 or 6 metres of sea level rise over the coming few hundred years, that would cause huge problems, especially again to many developing countries, but for many developed countries in terms of, you can think even around Nelson, how many things are probably within 7 metres of sea level. So those are the reasons people are concerned about climate change and why there's all of this discussion internationally about international negotiations to reduce emissions. And from that work that scientists have done about vulnerability, the general idea seems to be coming through that we should try not to get any more than a couple of degrees or so of warming compared to pre-industrial times. Once we go beyond that, we really are probably getting into some pretty dangerous territory. The problem is, again, this is out of work that was done for the IPCC, if we want to keep below about 2 to 2.5 degrees, we'd have to limit what's called the CO carbon dioxide equivalent concentrations in the atmosphere to somewhere around about under sort of 450, 500 parts per million. And that would require us to actually really turn things around. The emissions of carbon dioxide to the atmosphere would have to peak within about 6 or 7 years of now, by 2015, and we need to reduce them by between 50% and 80% by 2050. So this is not just screwing a few energy efficient light bulbs in, this is a major change to the way the world works if we're really going to try and aim for those sorts of changes. So that's, I hope, set the framework a little bit about why I think that things like Code Red really are so important, that we really do need to be changing the way we make use, particularly of fossil fuels, to try and reduce those carbon dioxide